There is a gravity hole in the Indian Ocean, a spot where Earth's gravitational pull is weaker, its mass is lower than normal, and the sea level dips by over 328 feet. This anomaly has puzzled geologists for a long time, but now researchers from the Indian Institute of Science in Bengaluru, India, have found what they believe is a credible explanation for its formation: plumes of magma coming from deep inside the planet, much like those that lead to the creation of volcanoes. To come to this hypothesis, the team used supercomputers to simulate how the area could have formed, going as far back as 140 million years. The findings, detailed in a study published recently in the journal Geophysical Research Letters, center around an ancient ocean that no longer exists. Humans are used to thinking about Earth as a perfect sphere, but that's far from the truth. The Earth is basically a lumpy potato, said study co-author Adaryi Ghosh, a geophysicist and associate professor at the Center for Earth Sciences of the Indian Institute of Science. So technically it's not a sphere, but what we call an ellipsoid, because as the planet rotates, the middle part bulges outward. Our planet is not homogeneous in its density and its properties, with some areas being more dense than others. That affects Earth's surface and its gravity, Ghosh added. If you pour water on the surface of the Earth, the level that the water takes is called a geoid, and that is controlled by these density differences in the material inside the planet, because they attract the surface in very different ways depending on how much mass there is underneath, she said. The gravity hole in the Indian Ocean, officially called the Indian Ocean Geoid Low, is the lowest point in that geoid and its biggest gravitational anomaly, forming a circular depression that starts just off India's southern tip and covers about 1.2 million square miles, 3 million square kilometers. The anomaly was discovered by Dutch geophysicist Felix Andries Venning Meinesz in 1948 during a gravity survey from a ship and has remained a mystery. It is by far the biggest low in the geoid, and it hasn't been explained properly, Ghosh said. To find a potential answer, Ghosh and her colleagues used computer models to set the clock back 140 million years in order to see the big picture, geologically. We have some information and some confidence about what the Earth looked like back then, she said. The continents and the oceans were in very different places, and the density structure was also very different. From that starting point, the team ran 19 simulations up to the present day, recreating the shifting of tectonic plates and the behavior of magma, or molten rock, inside the mantle, the thick layer of Earth's interior that lies between the core and the crust. In 6 of the scenarios, a geoid low similar to the one in the Indian Ocean formed. The distinguishing factor in all 6 of these models was the presence of plumes of magma around the geoid low, which along with mantle structure in the vicinity are believed to be responsible for the formation of the gravity hole, Ghosh explained. The simulations were run with different parameters of density for the magma, and in those in which the plumes were not present, the low did not form. The plumes themselves originated from the disappearance of an ancient ocean as India's landmass drifted and eventually collided with Asia tens of millions of years ago, Ghosh said. India was in a very different place 140 million years ago, and there was an ocean between the Indian plate and Asia. India started moving north, and as it did, the ocean disappeared and the gap with Asia closed, she explained. As the oceanic plate went down inside the mantle, it could have spurred the formation of the plumes, bringing low-density material closer to Earth's surface.